This video covers the standard setup for DC and DC pulse. The first thing you will want to do is to select your TIG mode with the TIG button here. At the top you have DC, then you have AC, and then you have AC-DC mixed wave. So for DC we are going to select the top DC setting. The next button along is the AC waveform. As we are setting up the DC, we won't need to touch this, as there will be no LED option when DC is selected. We will cover AC setup in a separate video. Now you should select your trigger setting for your torch. You can choose from 4 different trigger settings: 2T, 4T, 4T cycling mode and spot mode. You can find an explanation of how these modes operate in the operating manual. 2T is your best bet for a basic setup, as the arc will strike when you press the trigger and extinguish when you let go of it. Here you have the option to turn the HF on or off. Leaving the HF on is the easiest way of striking the arc, as it is a non-contact start method. When using this method, you bring the tungsten within 2 to 4 millimeters of the plate and simply press the on torch trigger or foot control, and it will create a high frequency spark that will jump from the torch to the material that you're welding. This will then form the welding arc. If you turn the HF off, you won't have that option, and this will now change to lift arc. With lift arc, the tungsten will have to make contact with the material being welded. To do this, you press the trigger, make contact with the material, then lift it off. When your torch is lifted off, this will now form the welding arc. Here, you also have the option to turn your pulse on or off. We will just do a standard DC setup first, then we will come back to the pulse option later on. To make your way through the various settings, simply rotate the dial to switch between each of the parameters. You can adjust within the TIG process. To adjust the desired parameter, you simply press the dial in. This will allow you to increase and decrease the value of the parameter that you have selected. The first LED diagram you will come to is for your pre-flow gas. What this means is the time in seconds of gas flow before the arc starts. For example, if you set it for 0.5, that will allow half a second of gas flow before the arc has started. Next on the diagram is your starting amperage. Depending on your requirements, you can choose to set a higher or lower starting amperage compared to your peak amperage. Following on from this, altering the slope in time, which can be set up to a maximum of 15 seconds, determines the time taken for the starting amperage to reach the peak amperage, which you will set next. The peak amperage is also the main welding amperage and should be adjusted to suit the thickness of the material being welded and your application. A good starting guide for peak amperage is 30 amps per millimeter thickness of material. For example, here we set the amps to 200, the slope time to 7 seconds, and the peak amps to 100. This will mean that the machine will strike the welding arc at 200 amps, and then over a period of 7 seconds, reduce the amps to meet the peak amps of 100. Having a higher starting amperage can be useful to ensure you're getting enough heat to form a weld pool when trying to weld thicker sections of metal. If you do not intend to use this feature, you can simply set your slope in time to 0.0, and then it will now automatically start at your desired peak amperage. The next LED along from the diagram is slope down. This is the same feature as the slope we have just talked about. However, instead of the amperage sloping at the beginning of the weld, the slope out will slowly reduce your amperage when you let go of the trigger at the end of the weld. You would simply select your slope in time here and select your desired finished amperage here. Once your finished amperage has been reached, the welding arc will extinguish completely. Again, if you don't wish to use this feature, simply set your slope out time to 0.0 and then it will just turn off straight away and skip this option. The next parameter on the diagram is post-flow gas. This is the same principle as pre-flow gas, but will come into effect at the end of welding. This should be adjusted based upon the peak amperage used. Higher amperages will require a longer post-flow gas time to ensure the tungsten electrode is shielded by a steady flow of argon gas while it is cooling. For example, at 100 amps, I'm going to set my post-flow gas to 4 seconds. Put simply, once the welding arc has extinguished, the gas will continue to flow for 4 seconds. The last parameter that can be set when using a standard DC TIG is your tungsten diameter. Currently, this machine is set up for a 2.4 diameter tungsten. Next to this is a little amber light, the parameter alarm. This alarm will illuminate when the amperage you are using exceeds the recommended amperage for a given tungsten diameter. It will also illuminate when the amperage is too low, but this is less important than if it were too high. It is important to note that this parameter alarm will not stop you from welding and won't affect the performance of the machine itself. It is only there to give you a guide and warn you that based on the setup you currently have the machine set at, the tungsten diameter isn't actually correct, or you have the wrong amperage. Okay, so that is your standard setup for DC. Now we will go ahead and show you through the DC pulse setup. Pulse welding can be useful for controlling heat input into material and can reduce the risk of burning through on thinner sections of material. The way in which it achieves this is by alternating between a high amperage, known as your peak, and a lower amperage, known as your base amperage. The speed at which it does this is known as your pulse frequency, which is measured in Hertz. We will look at this in more depth shortly. To go into your DC pulse setting, you simply go down to the pulse button here and select Pulse Function, which is the bottom icon. In the pulse setup, all of the settings in terms of pre-flow gas, start current, slope in and slope out, that kind of thing, are all still relevant and operate in the same way as the standard DC settings. This time, however, as we have just discussed, as well as the peak amperage, you will have to select a base amperage. As a basic setting, the base amperage should be set at 50 to 60% of whatever your peak current is. For example, if I set the peak amperage to 100 amps, I would set the base amperage to 50. As mentioned earlier, pulse frequency is a parameter that determines the speed of pulses and will need to be adjusted to suit your application. Pulse frequency is typically measured over a period of 1 second, and as such, a pulse frequency of 1 will give you 1 pulse every second. In layman's terms, 1 pulse is equal to 1 complete amperage cycle, going from your peak and then down to your base amperage. This machine will allow you to change your pulse frequency from half a pulse per second to 200 pulses per second. When used correctly, higher pulse frequencies allow you to achieve narrower weld beads and give you a more focused welding arc, as well as greater control. The other setting to change in pulse is called pulse balance. This is the balance of your peak and base amperage. So, for example, we set this to 50%. It will spend an equal amount of time in the peak as it will in the base. So, if you have it set to 1 pulse every second, it will spend half a second in the peak amperage and half a second on the base amperage. If you adjust this to, say, 75%, this will now spend 75% of the time on the peak amperage and only 25% on the lower base amperage. Thanks for watching this video. Please subscribe and check out our other videos.